All right, good morning, everyone, and welcome to our first webinar as part of the Forage Month webinar series hosted by the Alabama Cooperative Extension System. This month, we'll be hosting a series of webinars on Tuesdays and Thursdays at 10 a.m. Central Time. So I'm Audrey Gamble. I'm a soil scientist with the Cooperative Extension System, and I will be kicking off the webinar series by talking about soil fertility and soil testing. So one of the reasons that we're starting this series with soils is because soils can really be considered the foundation for all that we do in animal production systems. We know that in order to produce healthy animals, we have to have good quality forages, and in order to produce those forages, we have to have fertile and healthy soils. So just starting with the basics of soil fertility, there are 17 essential nutrients for plant growth, and 14 of those are supplied by the soil. Those 14 nutrients can be divided into our macronutrients and our micronutrients. So macronutrients are those nutrients that are needed in the largest amount. Particularly nitrogen, phosphorus, and potassium are needed in very large amounts by plants, followed by calcium, magnesium, and sulfur. Then we have our micronutrients, which are still essential, but they're needed in much smaller amounts. Soils retain these nutrients through a process that we call cation exchange capacity. So we know that opposites attract, and soils have a negative charge, and that negative charge on the soil surface can retain positively charged nutrient cations like potassium, calcium, and magnesium. However, in our soils in Alabama, we deal with soils that are highly weathered. Some of our soils in the southern part of the state have very high sand content, and these don't carry a very high CEC. So as an example, I have a picture of this Tacklet soil series. This is a soil that is primarily made up of kaolinite and several iron and aluminum oxides. And so all of these minerals have a pretty low CEC when you compare them to minerals which may be more common in more fertile soils, for instance, of the Midwest of the United States, where we have more montmorillonite and vermiculite. So you can see we have our CEC unit expressed in basically the amount of charge per amount of soil, and you can see that kaolinite and quartz, which is sand, are much lower. Sand is practically nothing when you compare it to minerals like montmorillonite and vermiculite. So because of this, we really have to work to manage our soils, manage our fertility, manage our soil health. You can see that at the bottom of this chart, I have humus listed, which is a component of organic matter. So if we can build up organic matter in our soil, that also contributes to cation exchange capacity. So we really have to just work to maintain fertility and soil health in order to maintain good forage production systems in Alabama soils. So I like to think of nutrients in terms of budgets. So in with any nutrient, we have inputs, we have exports, and we have losses. So inputs can include things like fertilizer, manure. If you're talking about nitrogen, legumes can be a source of nutrients since legumes take nitrogen from the atmosphere and convert it to plant available form. Also, if we're in a pasture system, feed can be considered a nutrient input because we have, for instance, corn gluten or soil hulls. Those all have nutrients within them, and those get redeposited on the field as cows graze. Then we also have our nutrient exports, and these are intentional removals of nutrients. So hay removes a lot of nutrients when we remove grass from our fields. And then also calves and beef can remove some nutrients, although much less than hay. And then nutrient losses are unintentional removals of nutrients. So that can include runoff or leaching processes in the soil. So we know that when we're talking about nutrient cycling, we really have to think about hay forage systems and pasture forage systems very differently, because in pasture systems, animals are recycling a good amount of nutrients to the soil. And although this isn't necessarily an equal distribution across a field, we are recycling those. So of course, nutrients are typically concentrated where cattle will feed, seek shade, drink water, and those areas will have typically a much higher nutrient concentration. But with improved grazing management, which I'll talk about later on in this presentation, we can also help improve that nutrient distribution. So continuing with the conversation of how nutrient cycling is very different in hay and in pasture systems, this is a good graph to illustrate this. So in this graph, we have nutrient removal in pounds per acre of 3 of our macronutrients, nitrogen, phosphorus, and potassium. And we have these compared in Bermuda grass pasture systems and Bermuda grass hay systems. So the blue bars are representing Bermuda pasture and the removal of 500 pounds of beef. So with each 500 pounds of beef that we remove, we're removing 13 pounds of nitrogen, 8 pounds of phosphorus, and about a pound of potassium. However, in a Bermuda grass hay seasonal production, for instance, if we remove 8 tons of hay, that's removing approximately 400 pounds of nitrogen, almost 100 pounds of phosphorus, and about 350 pounds of potassium. So that's a very significant amount of nutrients that are being removed from the soil that have to be replenished. So the best way to find out what nutrients you need in your soil is through soil testing. So following soil test recommendations for maintaining fertility is important to help producers achieve their maximum forage production, as well as decrease disease and weed infestations in fields. Because if we have a good stand of healthy forages, that helps protect against some of those weed and disease problems. So when you're sending your soil samples to a soil testing lab, like Auburn University Soil Testing Lab, you can be ensured that the recommendations that we give at Auburn are based on research, which correlates the amount of yield increase that we see with increased levels of soil nutrients. For example, phosphorus. As those soil test levels increase, we see an increase in yield up to a certain point at which adding no more phosphorus will contribute to increased yield. So soil testing is there to help you reach that critical soil test level where we're maximizing production without putting out excessive nutrients. Because we don't want to put out excessive nutrients for 2 reasons. 1, it can be a waste of money, and 2, certain nutrients like nitrogen and phosphorus, when they get in our water sources, can be damaging to the environment. So for pastures and hayfields, we recommend taking samples to a depth of about 3 to 4 inches. It's important to remember that your soil test is only as good as the sample you take. You know, we're using just a few grams of soil to make recommendations for your entire field. So it's important to get a large number of subsamples. We recommend at least 20 subsamples, especially for pastures, because again, that nutrient distribution is so unequal in pastures. So making sure that you go throughout your field and randomly collect those samples, mix them all together, and put them in a soil test box for analysis. We recommend that for hayfields, you soil test every year, because again, we have a lot of nutrients that are being removed in hay systems, and then for pastures, every 2 to 3 years. We also recommend taking separate samples for different soil types. So if you know you have soils that are very sandy in one part of your field, and then soils that are more clay in another type, it's important to sample those separately, because nutrient recommendations will be calculated differently for those 2 different soil types. It's also important to sample areas of the pasture that are managed differently separately, and it may be a good idea to sample areas which perform better than others separately. So if you have an area where you know you have pretty poor production, you may want to sample that separately from an area where you have really good production, because the nutrient content could be different in those soils, and you want to account for that. So once you have your soil sample, you can put it in a box that's provided by the Auburn Soil Testing Lab. These can be acquired at any of your local extension offices, as well as these soil testing analysis forms. So on these forms, we just ask for basic information. You name your own sample, the amount of acres it's representing, and then the crops and plants that will be plant that will be planted there in the next season. And so for forages, it's important to distinguish whether those are going to be managed as pasture or as hay, because again, those nutrient recommendations will be different. As I mentioned earlier, sampling different soil types is important because our recommendations will be different. In Alabama, we group our soils into 4 different categories. So soil group 1 is going to be your really sandy soils, primarily in the coastal plain region that have a very low cation exchange capacity, and then that increases. The soil group changes as cation exchange capacity increases. And then our soil group 4 is clays of the Black Belt region, which we even use a different type of extractant to analyze those because the soils are so different. So this is an example soil test report that you may receive from the Auburn University Soil Testing Lab. So again, this shows that nutrient recommendations are going to be different for hay versus pasture. Here we have a soil, this is the exact same soil where we have a soil group 2, pH of 6.1, extremely high phosphorus, medium potassium, and high calcium and magnesium. But you'll notice that for the Bermuda grass hay, we have different recommendations for the than for the pasture. So for the hay, we're going to recommend more nitrogen and more potassium because more of those nutrients is going to be removed as hay is removed. It's also important to pay attention to the comment section of a soil analysis report because this may have extra bits of information that you don't see in these recommendations in the chart. And so an example of this is for alfalfa, we'll recommend applying 3 pounds of boron per acre annually. So these maybe specific micronutrients that might need to be added will be included in the comments. Also some information about how to split your applications or when to apply will be included in the comment section. So now I just want to go through a few of the major nutrients or macronutrients and talk about their cycling in soil and what our recommendations will look like. So the nitrogen cycle is one of the most complex in soil, and this is one of the reasons that we don't actually analyze the soil for nitrogen content because it changes so frequently. And this is the same for any of the commercial labs or university labs within the Southeast. But we have our inputs of nitrogen, including atmospheric nitrogen that's deposited, and then manures, fertilizers that are added, as well as decomposing plant residues. And one of the reasons that nitrogen is so unique is because it is very prone to leaching, and so that's one way that nitrogen changes frequently, especially in sandy soils, because we do have a lot of leaching of nitrate to deeper soil depths and even into the groundwater. Nitrogen that's in more labile forms, like in manures or certain fertilizers like urea, can be prone to volatilization. So that's something to consider as well. So as I mentioned, we don't do a soil test for nitrogen, but your nitrogen recommendations will be based on what type of forage you're growing and what the management is going to be. So I mentioned before that approximately 50 pounds of nitrogen is removed in 1 ton of Bermuda grass hay as an example. For most of our forages, Auburn will recommend 60 pounds of nitrogen before green up for pastures and 100 pounds for hay. But that 100 pounds is not the end of your nitrogen application. We recommend that after each hay cutting, 50 pounds of nitrogen is applied per ton of anticipated hay removal for the next cutting. Because again, if you're, for each ton of hay that you're removing, you're taking out about 50 tons of hay. So splitting that nitrogen application will help to ensure that you minimize your losses through leaching and that nitrogen is available to the plant. Another option to consider for a method of nitrogen fertilization is overseeding with legumes. Legumes can be a great source of nitrogen. I have here a graph showing the hay grass production in a field that was overseeded with legumes. I have data for crimson clover presented here, but the same study was also repeated for 2 other clovers. I believe it was subterranean clover and airleaf clover. And so you'll notice here we have different nitrogen rates in pounds per acre. So there's a nitrogen rate of 0, 50, 100, and 200 pounds per acre. So if clover, for Bahia grass that was not overseeded with clover, in this instance, there was about 1 ton of dry matter produced when there was no nitrogen applied. However, for Bermuda grass with crimson clover overseeded, again, no nitrogen applied, you're getting about 7,000 pounds per acre of dry matter. So to reach that same amount of dry matter production with nitrogen application, you'll have to be probably in the 150 pounds per acre range, maybe even a little bit higher in this case, to reach that same amount of production. So for that reason, we recommend that in pasture systems, if 30% of the forage stand is a legume, no additional nitrogen fertilizer is required. And of course, in hay production, you'll want to account for those additional hay cuttings. So potassium is another nutrient that's very important in forage production systems. We know that potassium is essential for many plant functions, including photosynthesis, protein synthesis, starch formation, water uptake, and lodging reduction. And deficiencies of phosphorus can result in increased weed and disease infestations, as well as winter kill. So potassium deficiency will show up on many grass species as a yellowing around the outer edges of the leaf. And again, because that can increase susceptibility to disease damage, you often start to see disease damage following potassium deficiency as well. So it's very important to soil test because potassium rate will be highly dependent on soil type. So for pastures, put out potassium according to soil tests before spring green up, and then in hay production systems, because large amounts of potassium are removed, it can be a good idea to split potassium applications, especially in sandy soils, because potassium, although it's not as prone to leaching as nitrate, it can leach in soils, particularly sandy soils. Another process that affects potassium availability is the fact that forages will uptake more potassium than they actually need. We call that luxury consumption. And so again, splitting applications can help with potassium availability by preventing luxury consumption and leaching in sandy soils. So phosphorus is the last of our 3 main macronutrients to talk about. Phosphorus is essential for root growth, for plant reproduction, and for improving yield. So again, phosphorus, depending on soil type, highly dependent, and so it's important to apply that according to soil tester recommendations. But the best time to apply is really whenever fertilizer is the cheapest. It doesn't matter too much when phosphorus is applied because it is not prone to leaching in the soil. So as long as best management practices are used to apply phosphorus, it really doesn't matter too much what time of year you're applying. Just as kind of a note that I added here, litter typically has a 3-3-2 nutrient analysis. So the most litter that would be recommended to, even if a soil is rated very low, 3 tons of litter can supply all of those phosphorus needs. And so litter can be a good option for pasture and for hay systems to supply your phosphorus needs, as well as get some supplemental nitrogen and potassium in there as well. I'll just briefly mention sulfur. Sulfur is essential for protein formation, for maintained root growth, and nitrogen fixation. And deficiency can result in yellowing, as shown in this picture here. Typically, sulfur is not going to be a problem in our pasture soils. We get a certain amount of sulfur released by atmospheric deposition each year. So typically around 9 to 12 pounds per acre from atmospheric deposition. And then depending on organic matter content of your soil, you'll also get sulfur release there. So for a soil that contains approximately 2% organic matter, that would be about 6 to 10 pounds per acre of sulfur. So that's plenty of sulfur to supply forage needs in pasture systems. However, if you're a very high yielding hay producer and you're removing, say, 8 or more tons of hay per year, that's going to be a lot of sulfur that's removed from the soil that may not be replenished very quickly. So it can be a good idea to add about 10 pounds of sulfur in with your fertility. A good way to do that is just by applying part of your ammonium or a part of your nitrogen as ammonium sulfate. Let's see. So probably what I would consider the cornerstone for soil fertility is making sure that pH is maintained, because if you're not at the right pH, a lot of those nutrients that you are applying may not be available to the plant. So for most of our forages, the appropriate pH to maintain is going to be somewhere between 5.8 and 6.5. That does change depending on forage. As mentioned previously, alfalfa is a forage that requires a little bit higher of a pH, a little bit higher maintenance. So it's important to follow soil test recommendations for liming to maintain pH for your forage. So for a lot of our macronutrients, the availability of those nutrients will increase with increasing pH, but for many of our micronutrients like iron, manganese, and zinc, the availability of those nutrients is going to decrease with increasing pH. So again, making sure the pH is maintained will help to ensure that all of your nutrients that are required for plant growth are in plant available forms. Micronutrients, I'll just briefly mention that these are typically not going to be a problem in our forage production systems, but of course, outliers do occur, and so we don't have good methods to soil test for micronutrient availability, but a good way to test if you think you might have a micronutrient problem in your soil is through plant tissue sampling. So foragers are going to have a sufficiency range for various elements, and the Auburn Soil Testing Lab or other commercial labs can run those tests to determine if your forage is in the appropriate sufficiency range if you think you have a problem. So what I want to close up with is really talking about managing fertility and pastures. I'll focus on pastures from here on out. But improved grazing management can really help to improve your nutrient use efficiency in forages. And so we know that overgrazing results in reduced coverage of the soil, which can lead to increased soil and nutrients loss as runoff. This graph here shows runoff and phosphorus loss so runoff is represented as a percentage of total rainfall, and phosphorus in parts per million phosphorus loss in various grazing systems. So we have ungrazed pasture, hay, and then various grazing systems. So you'll see that for rotational grazing and continuous grazing, when forages, I can't remember exactly what forage this was in, but this was an overgrazed scenario where overgrazing resulted in a greater percentage of total rainfall running off, as well as a greater amount of phosphorus loss from your system. So the best way to avoid this is through improving your grazing management, using rotational grazing, and preventing overgrazing in pastures. And that will not only reduce erosion and nutrient loss, but it'll also help increase organic matter storage, which again is important for nutrient holding capacity of soil. And then maintaining proper grazing height can also help to improve water infiltration and suppress weed growth. And again, that results in manure that's more uniformly distributed, particularly when grazing pressure is increased temporarily and cattle are rotated frequently. So this is a heat map, and this is coming from North Carolina State University. It's a map of one of their beef units. And this just shows how unequal nutrient distribution can be within a pasture. In this particular heat map, the red areas are low in phosphorus, and the blue areas are extremely high in phosphorus. And you can just see in those historic feeding areas how much higher the nutrient concentration is. And so there will be a webinar on grazing management this month, and so that's a great place to learn more about grazing management, which will in turn help with nutrient distribution. Lastly, using forages with different maturity dates can also help improve nutrient distribution in pasture just by extending your grazing season. So when we extend our grazing season and less hay is fed, it's more likely that those cattle are going to be moving throughout the pasture and distributing nutrients more equally. And I'll also point out that different forages can have different benefits. For example, grasses that produce a high biomass can help scavenge for nutrients, and those also help to prevent runoff. Legumes like clovers can, again, fix nitrogen from the atmosphere and be an additional of nutrients. And then brassicas like radishes and turnips have deep tap roots. Those can potentially scavenge for nutrients deeper within the soil profile and have also shown the ability to decrease compaction in certain scenarios. And so that's all I have for you today. If you have any questions about this presentation, feel free to contact me. My email and phone number are listed here. And be sure to visit alabamaforages.com to sign up for the Alabama Forage Focus Extension provide updates on publications and events for the Alabama Forage Focus program. And the next Forage webinar will be on Tuesday, June 7th, and it will be on pasture pest management. That should say Thursday, June 7th. Thursday, June 7th, and Dr. Kelly Palmer will be talking about pest management. For more information on Alabama Forages, you can visit alabamaforages.com again, or you can email alabamaforages@auburn.edu. Thank you.